We're going to begin with parabolas that have vertexes at the origin at 0, 0. And I can tell from these equations here that we have a vertex at 0, 0 because I have no h and I have no k. When we get a little bit further into this lesson, our equations are going to look a little bit more complex because we're going to have x minus our h or minus our h at the end and y minus k also in that. But here I just simply have a y squared or an x squared, and then just x and y. Okay, so nothing in parentheses, basically. Now, you can use, once you figure out which way this opens, whether it opens right, left, up, or down, I guess down right here, you can use that version of the formula, and then you have your focus point and your directrix line. If you want to use these, that's fine. I said in ellipse and hyperbola that I really like to not use the formulas and just graph. If you like these, please use them. But with parabolas specifically, I really like just graphing to find these points. So I'm not going to be using these, but if you prefer to use this, please do so. Now, while this box is really helpful, I think this right here is actually the most helpful. So I'm going to be kind of referring to these four diagrams and equations, which honestly have those points all on there, and then the equations for the directrix line. So even that has this on here with all of the equations down here. So these are saying the exact same thing. But if we kind of compare these equations here, it seems to me like the hardest part might be which graph am I going to get, which formula am I going to get. So if we can see that we want to look at the relationship between things. Kind of pay attention to the focus and the vertex. Is the focus to the left of the vertex or to the right of the vertex? Is the focus above the vertex or below the vertex? You can kind of look at the relationship between those. When I have the equation, compare your variables to each other. On this side here, I have y squareds. So when I have y squareds, it's going to open up to the right or to the left. So then how do you tell the difference between these? Look at your 4a. If your 4a is positive, it opens up to the positive. If your 4a is negative, it opens up to the negative. Over here, we have x squareds. When we have x squared, that's going to open up and open down, which we've actually graphed these before in module 2 because we were focusing on functions. These two here are not functions because they don't pass that vertical line test. So we've graphed these before, but when you have x squared and y squared, it's going to open up or open down. And then again, look at your 4a. If 4a is positive, it's going to open up towards all these positive y values. If your 4a is negative, it's going to open down towards all of these negative y values. Okay, so hopefully that helps a little bit. So example 1, plot these as we do them. Find the equation of the parabola with a vertex at 0, 0 and a focus at -2, 0. Let me put my vertex a little bit more down here. Okay. So look at the relationship between this focus and this vertex. Which diagram here has a focus on the left and a vertex on the right? And that's this one right here. You have your focus on the left and your vertex on the right. So it tells me I'm using this version of my formula. So we have y squared equals -4ax. So the only thing I need to be able to do this formula is my a. And my a is going to come from this diagram we put on that first page. That a tells me the distance from my vertex to my focus. So here, the distance from my vertex to my focus is 2. So plug in a 2 to this a. We have y squared equals negative 4 times 2x. So therefore, my equation is y squared equals a negative 8x. That is my equation. So now we need to graph this. A doesn't just tell me the distance from my vertex to my focus. It also tells me the distance from my vertex to my directrix. So if I went 2 from the vertex to focus, 2 to the left, I'm going to go 2 to the right. And let's go ahead and make it a straight line. Here is my directrix line. Okay, now I don't know why I made this down here. I don't know why on this they don't make this with a dashed line, but it is an imaginary line, so we're going to do it with a dashed line. So it's not really there. But I do want to label this equation. This is at x equals 2, which you can use this right here. X equals your A. And now what I need to plot is my 2 lattice rectum points. So we put on this first page as well that my LR equals 4 times A. So LR equals 4 times A. Which is 4 times 2. So LR equals 8. This right here represents the total length. So what I want to do is I want to take this number and divide it by 2 to tell me how many to go in each direction that will give me that total distance of 8. So from my focus, I'm going to go up 1, 2, 3, 4 points. Here is my first LR point, and I will go down 1, 2, 3, 4 for my second lattice rectum point. So now my parabola here goes from my vertex through those LR points. That LR will tell me how wide this is going to be. So now that chord that goes through that focus is 1, 2, 3, 4, 5, 6, 7, 8 units total in length. Let's go to the next page. We're going to do examples 2 through 4 as well. This one here gave me some information on how to get to my equation. Now I'm starting with the equation and I got to find the vertex, the focus, and the directrix. Let me fold this real quick. Actually, let me not fold it. I'm going to rip it. So take your volume down or whatever. Okay, one more time. I'm just going to use these pictures here because that's what I personally like. Okay. All right, here we go. So analyze this equation. Y squared equals 12x. And that is find the vertex, the focus, and the directrix, and then graph. Okay, if this is my equation, I'm just going to go ahead and write it down here. I need to compare this with the equation that this one is representing. So if I have a y squared, that tells me I'm using one of these two. And because this coefficient is positive, I'm using this one right here. So I'm going to write this formula right here below it. Okay, now that I'm comparing these two, notice you have y squared, you have x and x equals equals. What's different is this 12 and this 4a. So to solve for my A, I'm going to set these two equal to each other. We have 4A equals 12. So therefore, A equals 3. We are ready to graph and find the vertex, focus, and directrix. So I'm going to do this all at once because I like to graph to find this. Okay. So where is my vertex? Well, if in this equation, I don't have anything in parentheses with the x or anything in parentheses with the y, that tells me my vertex is at 0, 0. So now my focus, if this is my version of my formula, that tells me my focus is going to be over here to the right of my vertex. So I'm going to go A units from this vertex to give me my focus. So my focus is at the ordered pair 3, 0, which is what we have right here, A, 0. Then my directrix, I'm going to go the opposite direction, 1, 2, 3. And here is my directrix line. At x equals -3. So my directrix line is at x equals -3, which is what we have right here. X equals -a. And there are my 3 asks. So now we need to graph it. We need to finish this graph. Let me put little arrows here. We need to finish this graph by plotting your LR points. So your LR is 4 times A. Well, we already have that right here. 4 times A is 12. So this should be my total deep length of LR. So if this is my total length, I'm going to take LR of 12 and divide it by 2 to get 6. So from this focus, I'm going to go 6 units up, which is going to be one above my graph. And I'll go 6 units down. And so here is my parabola. So I'm going to start at the vertex and go through those LR points. So now my LR is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 units total in length. Example 3 is asking me the exact same thing to analyze this equation. So I'm going to stack my equations. I'm going to rewrite the one that I have here. And what is this equation representing of these 4? So now I have x squared. So I know I'm on one of these two. And because I have a -8y, I'm using this one right here. So we have x squared equals -4ay. So what's kind of different here? You have x squared and x squared equals y over y. But we have -8 and -4y. So if I set these two equal, divide by -4, and we get an A of 2. So now I'm ready to graph. Okay. It wants to know the vertex. And of this formula here, if I have nothing in parentheses with the x and nothing in parentheses with the y, my vertex is at 0, 0. Now, looking at this diagram here, after I plot my vertex, my focus is below. So I'm going to take this 2 and I'm going to go 2 units below for my focus, which is at the ordered pair 0, comma, -2, which is what that says right here. A comma, or 0, comma, -A. Then my directrix is above, so I'm going to go A units above, and my directrix line is right here. And that is at y equals 2, which is right here, y equals A. And so those are the 3 things it asks for. And now finish our graph. We do that by plotting our LR points. So LR equals 4A. My A is 2. So LR equals 8. This is my total length. So we need to take this and divide it by 2 to get 4, so I know how many to go in each direction. So from this focus, I'm going to go 1, 2, 3, 4, and 1, 2, 3, 4. Now we can go from vertex through that LR point. And if we count that distance, that's 1, 2, 3, 4, 5, 6, 7, 8 units total in length. Last example here. Find the equation of the parabola with a focus at 0, 3 and a directrix line at -1, 2, 3. So this is at y equals -3. Now, as I'm labeling that directrix every time, I do expect you to do that as well. So this one doesn't tell me where my vertex is, but I do know my vertex is in the middle of these 2 here. So where is the middle? Right here at the origin. So now let's compare all of our information. Which of my 4 graphs have a focus on the top, a directrix line below? This is left and right. This is left and right. Here, I have a focus on the top and a directrix below. So I'm using this formula here. A squared or x squared equals 4ay. Okay, the only thing I need for this is my a. Here, a is 3 up and 3 down. A is 3. So I have x squared equals 4 times a times y. So my equation is x squared equals 12y. So now to graph this, I need my LRs. LR equals 4 times A. 4 times A is 4 times 3. What's going to give me 12? So this is my total length. I'm going to take this and divide it by 2 to get 6. And that's how many I'm going to move in both directions. So from this focus, I'm going to go 6 units to the right and 6 units to the left. And then we'll connect our vertice or vertex and go through the LR. And so now we have a total distance of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A total distance of 12 for that entire lattice rectum line.